Very good afternoon to all my dear students. Today class I am going to discuss about the concept of induction. So in the previous classes we come to know that when there is change in flux and it induces EMF, means indirectly we are inducing current in a coil. So we can say that phi is the representation of induction. So induction is represented by the letter phi. And induction is not represented by this one. What is this one? Magnetic flux linked with the coil is directly proportional to I. That implies phi is equals to L into I. For a coil of N turns, N phi is equals to what? Li. Here N phi is called flux linkage, means how much flux is associated with n number of turns of the coil. That is called what? Flux linkage. Means this flux linkage is directly proportional to current flowing through the coil, and it is related by one proportionality constant, that is called what? Inductance. That we can call inductance. Now here briefly discussing about induction. Induction is classified into two types. One is self induction and another one is mutual induction. Self induction and mutual induction. So in this chapter let us clearly discuss about what is self induction or what is self inductance, how this self inductance of a particular object can be calculated. So let us know the concept of what? First we are saying that this is inductance, and the property of the material or the device which opposes the flow of current is called inductor. Like resistor. What the function of resistor? A resistor is a device used to oppose the current, and you know the symbol of resistor. So this is the circuit symbol of resistor. And one more device we learned, that is what? Capacitor. What is a capacitor? It is a device used to store the charge. Now here the term is comes, or the device that is inductor. What is the function of this inductor? Is it opposes the change of current. So you should remember this point here. There is a lot of difference between resistor and inductor. What the resistor will do? It opposes the flow of current. It opposes the flow of current. What the function of inductor? The inductor will opposes the change of current. Means it is not going to oppose the flow of current, it will oppose the change of current. How? Let us see here by using a simple experiment. Here the representation of inductor is this one. So this is the circuit symbol of an inductor. So how this opposes, this inductor will opposes this flow of current or change of current. Let us clarify here. What is that is? First concept I am discussing that self induction. Self induction. So for this we connected an inductor to a battery, which in turn is connected to a plug key. The inductance of the inductor is L. The battery is connected having some potential, and this is the function of plug key. Now what I am going to do is I am going to switch on the circuit. When you switch on the circuit, what happens? The current changes, right? The current starts to increase from 0 to I, because at an instant it cannot directly comes to I, right? It slowly increases and reaches a point I. So while increasing from 0 to I. What is increasing? Current, right? Yes. If the current increases, the magnetic flux linked with the coil also increases. N phi is directly proportional to I. So what happens here? The current is increasing, so the magnetic flux also increases. So what is changing? Magnetic flux. What is Faraday's law of electromagnetic induction? The amount of induced EMF is directly proportional to rate of change of magnetic flux. So this change of current causes change of magnetic flux. The change of magnetic flux induces EMF. Now what is Lenz's law? This law explains that change in flux or this induced EMF opposes the flow of current. So finally we can write a cycle here, right? What is that? When the circuit is switched on, the current increases. This current increases causes increase in magnetic flux. It implies what? Change of magnetic flux. This change of magnetic flux induces EMF. This induced EMF again opposes the change of flux, which in turn change of current. So finally what is happening here? This inductor opposes the growth of current, means change of current, right? Growth of current. Okay. Next, let us substitute that the current is switched off, right? When the key is open. When the key is open, what happened now? Slowly the current decreases from I to 0. Now the current is decreasing, means there is change of current, there is change of magnetic flux. This change of magnetic flux induces EMF, and this induced EMF opposes the change of flux, which in turn opposes the current, right? So in both cases, when the current is constant, there is no change of flux, there is no induced EMF, there is no opposition. But when the current is increasing or decreasing, what we observed? That inductor opposes this change of current. So that is the function of inductor. So we already said, right, what is an inductor? It opposes the change of current. What is the phenomena will go here? Current changes causes change of flux. This change of flux induces EMF, and this induced EMF opposes the change of flux, in turn change of current. So we can define the statement of self-induction as what? It is the property of a material. Is it right? It is the intrinsic property of the material. What it is doing? It is the intrinsic property of the material which opposes the growth or decay of current, means which opposes the change of current. That is called what? Self-induction. Why we are saying self-induction? The change of current happening in the same coil and inducing also happening in the same coil. So we can redefine the statement as, what can we define as the self-induction as? This is also important property, right? The phenomena of inducing EMF in a coil due to change of flux in the same coil, due to change of flux in the same coil is called what? Self-induction. So have you related this property anywhere in mechanics? Yes. What that property is? Inertia. What is inertia? The property of a material which opposes the change of motion. For example, if a body is at rest, it won't be at rest. If a body is in motion, it is in motion. A body is in motion, don't want to come to rest. A body is in rest, don't want to come to motion. So there it opposes the change of motion, and here it opposes the change of current. So, the property of self induction is very related to inertia in mechanics. So, this is about what? Self induction. Now, we have to define coefficient of self induction, that is the property of the material. Let us see how we can define. Have you observed here, when there is change in current, right, is directly causes change of magnetic flux. If it has n turns, the current is directly proportional to change of magnetic flux. Already we said that this is called what? Flux linkage. It is called what, ma? Flux linkage. That implies n phi s is equals to L I. So, we have to define L. So, L equals to what? N phi s by I. So, this is called what? Coefficient of self induction. So, how to define self induction? The coefficient of self induction is defined as, what is this? Magnetic flux linked with the coil when I is equals to 1 ampere, right. So, we can clearly say that it is defined as the magnetic flux linked with the coil when unit current flows through it. When unit current flows through it means when I is equals to 1 ampere, L is equals to N phi s. That is the definition, right. It is defined as the magnetic flux linked with the coil when unit current flows through it. Or we can define one more statement, right. According to Faraday's law of electromagnetic induction. According to Faraday's law of electromagnetic induction, what we can define? We already know that E is equals to minus d phi b by dt, right. For a coil of n turns, what we can define, ma? E is equals to minus n into d phi b by dt. Now, already we discussed here n into phi s or n into phi b is equals to what? L I. So, E equals to, instead of phi b, what we can substitute here? Sorry, n phi b minus d by dt of L into I. As we know very well, L is the property of the material which depends upon the nature of the material and independent of time. So, minus L, here what is changing? di by dt. So, we can define the inductance as what? L is equals to, if you take magnitude, E by magnitude of induced EMF by di by dt. Means it is defined as induced EMF in a coil when the rate of change of current in the coil is unity. Self inductance is equal to induced EMF of coil when di by dt is equals to what? 1 ampere per second. The same thing we can define the statement as, it is defined as EMF induced in a coil, when, what is the condition? di by dt should be equals to what? 1 ampere per second. So, we can write as when the rate of change of current is how much? When the rate of change of current is unity, means 1, right, ampere per second. So, we can define the statement of coefficient of self induction as two statements, that is L is equals to n phi s when I is equals to 1, means it is defined as the magnetic flux linked with the coil when the unit current flows through it, or it is defined as induced EMF in a coil when the rate of change of current is unity. Clear? Yes. Now, how can measure what is the SI unit of this inductance, right? We know what is the property of inductance, what it will do, and now we are going to know in which units we are going to measure. So, what are the units we can measure here? Is SI unit of inductance is what ma? Henry. H. Now, how to define 1 H? Simple. L is equals to E by di by dt, means this is 1 volt and this is 1 ampere per second. Inductance is said to be 1 Henry when see here, L is said to be 1 Henry, L is said to be 1 Henry when an EMF of 1 volt is induced in a coil when the rate of change of current in the same coil is unity. You should define the statement like this. What that? Self inductance of a coil is said to be 1 Henry, is said to be 1 Henry when an EMF of 1 volt is induced in the coil when rate of change of current, when the rate of change of current in the same coil is unity. So, we can get the doubt that, sir, why you are saying every time same coil, because if it happens in another coil, that the definition will be different. So, we should represent self induction, means we have to analyze, it has to produce EMF by its own, so that we are representing that self induced, self induction. Okay. So, this is about what? Self induction and self inductance. Now, I am going to derive the expression for important question for 3 marks. Expression for self inductance of a solenoid. Expression for what? Self inductance of a solenoid. So, for this we know very well what is solenoid. Take an insulating substance, on this an insulated wire is wounded. Insulating wire is wounded. Let us assume that the current flowing in this inductor is, solenoid is what? I. What is the length of the solenoid? L. So, let L be the length of the solenoid and small n be the number of turns, per unit length. Means what here? The total number of turns in the coil we should know now first. What is the total number of turns in the coil? Is capital N. The total number of turns in the coil was capital N. So, what we can write? N is equals to N by N. So, how to calculate the self inductance? Simple. If you want to calculate the magnetic flux linked with the coil, right? So, what is the magnetic flux linked with the solenoid? Magnetic flux linked with solenoid. Is it right? What is the magnetic flux linked with solenoid? Phi B is equals to B bar dot A bar. Nothing but B A. Here the area the magnetic field will be induced along the axis of the solenoid. So, both are along same direction. So, what you can write cos 0. So, what you get B into A. Okay. How many turns are there? N turns. So, for N turns, N phi B equals to, for N turns, N phi B is equals to what? N B A. Okay. But I don't know what is the magnetic field that is present inside the solenoid, right? We already derived in the previous chapter, moving charges and magnetism. What is that? Magnetic field inside a solenoid, magnetic field inside a solenoid along its axis. What is that? B equals to mu naught Ni. As we know, what is N? Number of turns per unit length, N by L. So, I can write this as what? B equals to mu naught Ni by L. Substitute equation number 2 in 1. So, from equation 1, what is N phi B? N into B into A, right? What is N? N only. What is B? Mu naught Ni by L into A. Okay, that equals to mu naught N square I by L into A. We know that the magnetic flux linked with the coil N phi B equals to L into I. What is N phi B? Mu naught N square I by L into Li. So, this L is length of the conductor, this is self inductance into A. So, I get cancelled, therefore, L is equals to mu naught N square A by L. So, the self inductance of a solenoid depends upon nature of medium, means for example, if it is same coil, if you take in a medium, can it will be same? No, not at all. L is equals to what? Mu N square A by L, or this can also be written what? Mu N square A by L, sorry, N square A into L. How? Because small capital N is equals to NL. So, this self inductance of solenoid depends upon nature of medium, square of number of turns, area of cross section and length of the solenoid. So, this expression is very important for 3 marks. So, this class is completely about what? Self inductance. Clear, right? Thank you.